Welcome to today's lesson on proportional hypothesis testing. Our objective for today, by the end of this lesson, I'll be able to understand how to conduct a proportional hypothesis test and why they are important overall. So when we look at the why of this situation, proportional polling, just like before, is one of the most commonly used statistics in the world today. And we can use a proportional hypothesis test to examine the validity of a claim value based on a sample from the same or similar population. So when we're looking at our theme for this unit, off of the Gallup poll, is college worth the cost? One question we could ask is, do recent graduates have a significantly different response than the overall population that we're dealing with in this study? Okay, when we look at our themes as we go through these questions, we definitely have some very similar themes. Number one is, can we trust our answer? Okay, we're testing our assumptions and conditions. Have a new situation here overall. Okay, so the first thing we want to look for, is it random? Okay, we look through the problem, a random sample. Okay, so we have to state the evidence. Random sample, stated in problem. Okay, we have to show the person that's reading our answers that we've looked through and found and validated that. When we look at independence, remember, independence is 10 times n. Is that less than the population size? Okay, we have to be careful. We have two sample sizes here, but in this case, our little n is 17,000. So 10 times 17,000 equals 170,000, okay, which is the less than the population of all recent, and we look at recent, the last 10 years. College graduates. Normal sampling distribution. Okay, once again, when we're talking about proportional problems versus mean value problems, we have to do our n times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. When we're dealing with the size of these values, and we're going to have to look at, what is the proportional value that we're looking at. So we'll jump and just real quick look at our null hypothesis, because that's going to give us our proportional value that we're going to test. Okay, we're testing off of the assumed value. So we have 17,000 times 0.5 equals 8,500, okay, which is definitely greater than or equal to 10. 17,000 times 1 minus 0.5 is once again 8,500, which is greater than or equal to 10. Okay, so in this case, it doesn't happen in all cases, but in this case, we've verified all three assumptions. So we know that the answer that we get is a very valid answer. It's an answer that we can trust overall. When we look at hypothesis tests, there's one extra piece that gets added in, and it is our null and alternative hypotheses. And when we're writing our null and alternative, we're always working off of what we assume is true, and we're trying to prove otherwise. So when we write our alternative, remember the sign is based on the wording of the question. They can tell you less than, they can tell you greater than, but then they also use the word differs. And if they say that it differs, we know that there can be just as likely a lower tail that matches the upper tail, or vice versa in that situation. Okay, like always, make sure that you state everything in the context of the problem. So now we've looked at the stats on the strongly agree situation with, is my education from blank university worth the cost? Okay, and we have this overall value of 50% that say that they strongly agree with that value. Now, if we notice the recent graduate data, okay, they've broken it down by how much student loans the individual has, and using those student loans to judge their overall satisfaction. So the hard part is it's not an apples to apples comparison. So let's look at the best case scenario for recent grads. The best case scenario for a recent graduate is they have zero debt when they graduate, okay? And it seems likely that they would say it is more likely worth the cost than any other group here. Okay, so we're going to test that group as our sample population that we're working with. So based on that number, we can set up our null and alternative. Okay, the null hypothesis is the proportion of 06 to 15 graduates that strongly agreed with their education was worth the cost is equal to the claimed 0.5 for the overall population. And the alternative is the population, our proportion of 06 to 15 grads is less than that 0.5 value. So you want to make sure that you have both of these pieces along with your context listed in your answer. So now, our calculations. Okay, remember, every formula you need for hypothesis tests or confidence intervals is on your formula sheet. So make sure you go and use that resource overall. So when we're talking about tests, we're going to find our test statistic. And in this situation, proportional problems go back to the z value instead of a t value. So we need our statistic, our parameter. The parameter comes from the null hypothesis. And then the standard deviation of the statistic. Okay, this formula is on your formula sheet based on sample size and type of problem. Okay, so it helps organize it for you overall. So then using our values, we have a sample statistic of 0.49. Our parameter from our null hypothesis is 0.5. That's the center of our distribution. And then if you notice, we always use the parameter value for our standard deviation. Okay, and we can see why that would make sense if we look at the distribution. We're saying it's centered at 0.5. We're finding the probability of 0.49 or less. So if it's centered at 0.5, standard deviation is always based off of your central value. So we do our calculation. We get our z value of negative 2.61. And then we use that z value to write our probability statement. So when you're looking for what you need for full credit scoring, you need to show your z value calculation, and you need to show your probability statement for that situation. Now, one thing that we want to remember here, okay, what does the p-value represent? Okay, the p-value represents the probability that a random sample that is truly centered at 0.5 would be 0.49 or less. So when we're looking at that situation, that happens less than 1% of the time. So it's a rare occurrence. And what we want to remember is anytime we see the rare occurrence, less than 5% of the time, 5 times in 100, that's when we go to our rejection claim overall. Okay, now conclusion, the last piece of our problem. Okay, once again, we need 3 things for our conclusion to get full credit. You want to state your evidence. Okay, make your conclusion about the null. Do you reject it or do you fail to reject it? And then a statement about the alternative in context. Okay, this is the one piece that gets left out more than anything else because it takes a lot of time to write that context portion of your answer, okay, but it is critical for full credit. So then our context for this situation, our conclusion, based on our evidence, we always compare our p-value to our significance level. Okay, that's what allows us to reject the null. And then that evidence also supports the alternative hypothesis, which states the proportion of 06 to 15 graduates that strongly agreed with their education was worth the cost is less than 0.5. We don't know what the number is. 0.49 was our statistic, but we know that it was less than 0.5 overall. Okay, now, just like we saw in the confidence interval video, here there is always an alternative question they can ask. So we want to say, what else can we do? The question they can ask is, what proportion would we need to reject? So they're taking away the sample value that was given to us and asking us to solve for that sample value. So now, if they take away the sample value, they have to give us something to find z. Okay, and we will find that based on our significance level. Our significance level is telling us about the tail portion of the graph. Okay, and if we have a 5% low tail, that 5% low tail works with a z value of negative 1.65. So then we substitute in to our equation. And the one thing you want to remember, it's one of the most common solving techniques that you'll use in statistics, and it's just to cross multiply and solve. So in this situation, we want to cross multiply. We get p hat minus 0.5 equals, and then we'll run the numbers on this quick, negative 1.65 times the square root of 0.25. I'm just going to do that multiplication in my head for those top values to make the entry a little bit cleaner overall. Okay, and then we get an answer of negative 0.0063. And then to finish up, we add 0.5 to both sides. Okay, and then we find out the sample statistic value that would lead to that perfect rejection line is at 0.494. So as soon as we get to 49.4% of the population believes something compared to that 50% central value, okay, that's when we would lead to our rejection claim. Okay, now, additional practice besides your Schoology assessment, the in-class packet problems that are at the beginning of the unit, hypothesis testing questions in problems 1 through 4 are connected to today's lesson. Have a good day.